So we're getting good at doing calculations of environmental impacts. We've done a lot of calculations using dimensional analysis. We've calculated a bunch of carbon footprints, and we're even thinking about designing ecological footprint calculators to better understand the impacts of living on campus as an Allegheny student. And what I want us to do as we sort of approach the end of our first unit of this class is to start to think about calculating the environmental impacts of things like this Coca-Cola can that we have in front of us. And what you got to understand before we go too far down this road is that these things now exist in a highly complex and interconnected global economy where these things have lives that stretch across long periods of time and across vast swaths um, of the globe. Okay, and we need to consider this complexity when we start to calculate the environmental impacts of these things. Okay, so because these things have lives of their own, we often consider their entire lives in these calculations in what is called a life cycle assessment calculation. And just to get a sense of what this might entail, let's go ahead and take a look at the life of this can in front of us. How did it come into being? And what does that mean in terms of environmental impacts? Okay, so if you want to understand the beginning of a can, what you need to do is understand the raw materials that went into making that can. Okay, so I'm going to whisk you guys off to Australia or Jamaica or Brazil. These are all countries that have large amounts of bauxite ore. Okay, and bauxite ore is an aluminum-rich rock, clay-like rock that contains lots of aluminum minerals as well as iron minerals. And you can get a sense from these pictures of its sort of orangey red color. And I want you to start to think about what it takes to sort of pull this out of the ground and move it to a processing facility, right? Not only do we need to dig it up out of the ground and move it around, you need these huge pieces of equipment in order to do that. And you also need large amounts of water because when you're digging up rock like this, it creates tremendous amounts of dust. And the only way you keep the working conditions functional and safe is to keep things wet, to keep that dust down. So once you have bauxite, you got to get it off to a processing facility where you turn it into a white powdery substance called alumina. Okay, and this is alumina is basically the bauxite, except what you're doing is you're removing all the materials that are not basically aluminum oxide. Okay, so alumina means aluminum oxide. So we're getting rid of all the other materials. And this is actually a fairly energy and chemically intense process. So first you grind up your bauxite ore using this machinery that we can see off to the left. Once it's crushed, you sort of wash out mineral impurities that are easy to get away to remove just using water. And then what you need to do is to process the alumina first by heating the remaining material, dissolving it in chemical solvents, mixing it around, cooling it in a specialized facility where the white powder can be precipitated out to the bottom and removed from basically the chemical waste of that process. So once again, think about the chemical inputs, think about the waste that's produced, think about the energy that's required in order for this to happen. All of this has an environmental impact. Okay, we're going to leave Australia now because we're in a global economy. So actually what we're going to do is we're going to ship our alumina off to Iceland. Iceland that has built a really strong sector of its economy around aluminum production, basically the process of turning alumina powder into aluminum. So as you think about the life cycle of an aluminum can, think about also the transportation that happens and the environmental impacts of that transportation. Okay, big cargo carrying ships like this oftentimes burn fuel that is even dirtier than the gasoline that goes into your cars. Okay, now that we're in Iceland, okay, so Iceland has lots of rich energy resources, and the reason it has become a hub of aluminum production is because the process of producing aluminum from alumina requires huge amounts of energy, specifically electricity. Okay, so the way this process normally goes down is you start with your alumina, you heat it up to really high temperatures, basically enough to melt the aluminum ore that you end up with, and you mix that alumina into chemical solvents. And then what you do is you put it in a tub that allows you to force an electrical current through it, and you force electrons through basically this alumina dissolved in chemical solvents. And in the process of forcing electrons through, you change the chemical structure of these materials. Pure aluminum begins to precipitate out to the bottom of these containers, and you can pour it into vats and form it into basically metal bricks called ignats. Okay, and looking at these pictures below, you can start to get a sense of just how energy intensive this process is. But this process also is going to produce waste products as well. Okay, we're going to once again ship our material. We're not going to use a separate slide to show that, but we're going to ship it to the United States, where we actually do produce a large amount of aluminum cans. Okay, and what we have here is a can producing facility where we melt our aluminum ignats and use massive machinery like this to melt it, to stamp it into large sheets of aluminum, then to continually heat it and roll it into thinner, progressively thinner and thinner pieces of aluminum, which we can then cut and form into finished aluminum cans. Okay, once again, consider the environmental impacts of doing this. Once we have our can, we can fill it with some sort of liquid that is preferably desirable to consumers. And we still have to consider, once again, the transportation of those final products to grocery stores. We also need to consider the environmental impacts of the grocery stores themselves, which are facilitating the production and consumption of these products. Perhaps our aluminum can is sitting in a cooler, which is continuously using electricity to keep the drink cool. Perhaps the can is in a lighted grocery store, which uses energy just to maintain everyday operations. After you use the can, it also needs to be disposed of. So this requires more transportation. In the case of being tossed into a landfill, it will certainly take up area, which is another form of environmental impact. And if this can is going the route of a recycling program, it very well might be shipped back to another country, maybe a place like India or China, and melted down so that can be turned into more stuff later on. But you might also include the environmental impacts of that process if you're considering the overall impact of a can. Okay, so a lot goes into a can. Basically, there's many different stages that go into the development of a can, and all of these have environmental impacts. But also, you can get the sense that that these different stages also have many different kinds of environmental impacts. They're using water, they're using energy, they're producing emissions, and they're producing waste. So as we start to consider what it takes to calculate a life cycle assessment of a can, we need to take all of this into consideration.